Hello, today we are going to learn about equal sets. So what are the equal sets? Let's see. If every element of set A is in set B and every element of set B is in set A, then set A and B are equal sets. And we write it symbolically like this. A is equal to B. So what is the condition? All the elements of set A should be element of set B and all the elements of set B should be elements of set A. So this is the condition. Now let's see the example. For example, set A is a set of what? It's set of all x such that x is a letter of the word eat. Let's write this set A using listing method. Whenever we have been given set in this rule method form or in general form, we should write in the listing method. What are the elements of set A? What is the word given? Eat. So let's write each word, each letter of the word eats by putting commas. E, A and T. We have three letters without repetition. And now what's set B? Set B is a set of all y such that y is a letter of the word T. So therefore B is going to be equal to, what is that element of here? Set B. First letter is T and then E and then A. So both the sets are having three letters. But that is not enough. We need to check whether each element of set A is a set element of set B or not. E, yes, it is there. A, yes, and T. So these both sets are having three letters and both are set irrespective of the order. And that's why we can say that A is equal to B. That means set A and set B are equal. Okay. Now this concept can go for three sets also. Suppose one more set, suppose we have set C where it is the letter of the word, say, 8. In that case, I am writing here in short now. In that case, what will be C? C will be A, T, E. And if we compare these three letters are again same irrespective of the order, in that case, we can say set A is equal to set B and it is equal to C. So this concept of equal set can extend beyond two sets also. Now let's take one more example. If set A is given 1, 2, 3 and set B is given 1, 2, 3, 4, verify if A is equal to B, if A and B are equal. Now if you observe that here there are 3 elements and here there are 4 elements. Now the elements are not same, that's why it should not be same. Now which element is in B which is extra? The element 4 which is the element of B but not the element of C. So let's write reason as 4 is an element of set B but 4 is not an element of set A. Because of this extra element in set B, set A and B are not equal. We should write it symbolically. If this sign is for equal sets, this is not equal. Now let's take one more example. Set A is a set of all x such that x is equal to 2n, comma, n belongs to capital N, that is n means natural number set, and x is between 0 and 10. It is greater than 0 or equal to 0, it is less than 10 and equal to 10. So when such condition is given, we should write the set in the listing form. So what is set A? Understand this, every element of set A is x, and what is x? It is twice of n, 2 times n. N means, and what is n? It starts with, it's the element of natural number. Natural number starts with 1. So 2 into 1, if we take some, for suppose 2 ones are, it is 2. It is between, this condition also not, we will check. Greater than 0, less than 10. 2 twos are 4. Yes, it's up between this. 2 threes are 6. Yes, 2 fours are 8. Between this condition, 2 fives are 10. It is equal to 10 also, so we can come till 10. But if this 2 6s are 12, x is not less than 10, so we cannot accommodate 12 in this set. So we have here 5 elements, 2, 4, 6, 8, 10. Now what is set B? Set B is a set of all y such that y is an even number and y is between 1 and 10. Okay, so let's write B is set even number which is greater than 1 but less than 10 or equal to 10. So first even number 2, 4, 6, 8 and 10. As it is less than or equal to 10, we can take 10 also. And let's complete this bracket over here. Now observe we have 5 elements in set A and 5 elements of B. And each element of set A and B are exactly same. And that's why we can say that our answer can be, therefore our answer is A is equal to B. Thank you.